Okay, so there we go. I think it's got up there. All right, now, basically what we're going to do today is kind of an extension of what we've been doing already with the proofs. I would really encourage you guys to mark these diagrams up. When I was grading the quizzes yesterday, the main thing I was seeing that I think was kind of going against people were you were not marking stuff in the diagrams, and I think that makes it so much harder to do. So make sure we're marking in the diagrams when we're working on these problems. Okay, now what we're going to work on today, this is called CPCTC, and what that stands for, and you're on the right track, actually. The first word is, the first C is for corresponding. Are congruent. Yep, you're good. Okay, so it's like every other letter is C. So it's corresponding parts. Now, when I say parts, we're going to be talking about either a set of sides or a set of angles, one of the two. And so corresponding parts of, and I'm just going to use the symbol, congruent, and I'm also going to use the symbol for the word triangle. So corresponding parts of congruent triangles are congruent. So, yep, corresponding parts of congruent triangles have to be congruent. So when we're going to do the proofs today, they're literally just going to be one extra step. You're going to show that the two triangles are congruent, and what that's going to do is then force any other sides or angles that we didn't necessarily know were congruent from justification we did in the proof, forces them to be congruent. So what I just have in the very first couple problems is just to practice understanding what I'm talking about by corresponding parts. So this first set of triangles in this picture here, and these can be kind of tricky because you have to write out the congruent statement because they're not going to actually say, hey, prove these two triangles congruent. So you got to match up the corresponding parts when you work through these questions. But it says in the diagram to the right, and it says YHE is congruent to triangle, and then we have to fill it in. So if I call that first one YHE, can anybody raise your hand and tell me how would you have to label the second one? Good. So she says NMA. Perfect. Okay, now the options for why triangles are congruent, those are I've got them up on the board there, but you got side, 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 angle, side, angle, side, angle, and angle, angle, side. Those four options. Can anybody raise your hand and tell me, I have enough information marked in the picture right now. How do I know these two triangles are congruent? Which one of those that we've talked about? There's enough marked there. Angle, angle, side. Good deal. All right, so you got an angle, side, not in between. So angle, angle, side. All right, now, if the triangles are congruent, this is what else I can have. So that's enough information to prove the triangle's congruent. What it's going to do is force any other corresponding parts to be congruent to each other as well. Okay, so for example, angle H here corresponds to angle M here. So even though I didn't have that in the initial picture, because I know the triangles are congruent, that forces angle H and angle M to be congruent. And that's just because they're corresponding parts. They're corresponding angles. So if the triangles are congruent, any corresponding parts have to also be congruent. Now, those are all the angles taken care of. So for the sets of sides, I didn't know this initially. I'm just going to put a single mark. So HY and MN, those would be corresponding sides. So because the triangles are congruent, that forces that side H to Y and M to N, forces those two segments to be congruent. So even though we didn't know that, once we prove the triangles are congruent, we can have that information. And then finally, E to Y, I'm going to put a triple mark on that, and A to N, going to put a triple mark on that. So EY, AN, those two sides are corresponding sides. They both have to be congruent to each other if the triangles are congruent. Okay, now I'm going to do one more with you, but this one we got to do a little bit before we can say why the triangles are congruent. What else can I've got a set of angles here, angle C and angle R marked congruent, and I've got a set of sides, C to A and A to R, those are marked congruent. What else can I have in that picture that maybe isn't marked? I don't have any other given information, so I have to use a picture. Can I have any other sides or angles? Vertical angles for sure. Okay, so let me just go ahead and mark that in the picture. So we're not doing a proof or anything like that, but my justification for that would be vertical angles. All right, so I can have that from the picture. Now, this should be enough to prove that these triangles are congruent. So I called the first one PAR. How would I have to label the second one in the congruent statement there to make the corresponding parts match up? Perfect, TAC. All right, now, why are they congruent? Which one of the reasons? Awesome, angle here, right? Side in between an angle. So angle, side, angle. Now, because these now triangles are congruent, forces any other angles or sides that are corresponding to be congruent as well. So in terms of angles, I'm going to put a triple mark, angle T and angle P. Now those have to be congruent if the triangles are congruent. Because corresponding parts, which that would be a set of corresponding angles, those are congruent because the triangles are congruent. I can also have any of the sides. So in this one, I'm going to put a double mark C to T and R to P. Those sides would correspond to each other. So CT, RP. And remember, you guys can flip the letters around. Like I said CT, if you said TC, that's describing the same segment. I could put RP first and CT second when I write that. That's the same statement. We're just talking about those two segments. Say that one more time. Or PR, exactly. You can switch that up. So if it didn't match what I put exactly, that doesn't mean it's wrong. All right, and then the only other thing I don't have marked, I'm going to go 1, 2, 3 little slash marks, T to A, 1, 2, 3, A to P. T, A, and AP. Those segments have to be congruent. Even though we didn't know that initially, because we showed the triangles were congruent, we can have all that other information. Okay, so is anybody having a question at the moment? These are super similar to what we have been working on, these proofs. The main difference is instead of saying, I want you to prove these two triangles are congruent, it's going to say to you, I either want to prove a set of sides or a set of angles are congruent. In this very first picture, and don't mark this in the picture, don't mark this in the picture. It says prove angle C and angle F are congruent. So you absolutely don't know that. Do not mark that in the picture. Whatever you want to prove should be your last step. And so you'll notice the proofs we've been doing have had 4 steps. This has 5. So that will be, whatever you want to prove, that'll be your last step. So I'm just going to write that just to start out with. Don't mark that in the picture because that's what you're trying to prove. So you don't know that information until the very end. What I do have in the given information, and this is just practice, please just mark this in the picture. It makes it so much easier to do. So the first 3 steps should either be these sides are congruent or these angles are congruent, and then defend why. In this particular one, all 3 of them are going to be given to us. So I'm just going to go through and mark these up. So it says given AB, that segment, that side, and DE. So those 2 sides are congruent. That is a set of sides, so that's good for us. So I'm just going to come right over here and I'm going to say AB is congruent to DE. Set of sides, just totally given to us in the directions. And these can come in any order. I'm just going to go with how they have it worded in the information. So the next thing it says angle A, so I'm going to put a little curve on angle A, and angle D, put a little curve there. So angle A is congruent to angle D, straight up, just given to me in the directions. And then finally, it says AC, that's going to be a side, and DF, that's going to be another side. Those are congruent to each other. So again, I'm literally just taking this out of the given information. AC and DF are congruent, also given to me. Now, this is going to be the tricky part because usually in the question it tells you this triangle is congruent to this triangle and you're proving that. You have to write out the congruent statement for these questions. So just so we have all the same thing, I'm going to write triangle. Let me call the first one BAC. Okay, how would I have to label the other triangle so that they would match up? Perfect. EDF. Now, why And look at the picture, look at what you got, sides and angles that you got marked. Why are these two triangles congruent? SAS, this is a nice sassy triangle, I guess. Okay, side angle side. Now, I proved the triangle's congruent. That forces, so even though we didn't know this, do you guys see how C and F, I'm just going to kind of mark it on my picture a little bit, like this angle and this angle, they're in the same spot. C and F are in the same spot in the congruent statement. So that's a set of corresponding angles. So because the triangles were congruent, it forces these angles to be congruent. So this last step should be corresponding parts of congruent triangles are congruent. I'm just using that CPCTC abbreviation. Every other letter is a C there. And that, for each of these questions that we're going to do today, like that should be the last step in the proof. Whatever the parts are here, it was a set of angles, and then the justification will be that corresponding parts, congruent triangles have to be congruent. Okay, I'm gonna flip this over. Now, I numbered a couple angles in this diagram just to help us a little bit. Here is the deal though. I don't have a ton of given information here. I do have a picture, so we can use this. And I numbered more angles than what I can actually have from the diagram. So just going to emphasize this real quick. If you have parallel lines, which it tells me in the directions PR, I'm just going to kind of extend this a little bit, and QS, those two lines there, and I don't know why we cannot see that on the screen, so let me really take the picture. So RP, does that make it show up better? Yeah, I don't know, my highlighter wasn't showing it. Okay, so those are going to be parallel to each other. All right, now I'm just going to make a transversal. What two angles can I have congruent to each other from those parallel lines there? There's only two angles I can have congruent from those two lines being parallel. Does anybody know which two? They have a number on them. 2 and 4. Okay, good. So highlight if that helps you. That helps me see it better. So the parallel line and the transversal form angle 2, right? I have pink highlighter on both of these, and parallel line and the transversal here for angle 4. You cannot have angles 1 and 3. If I wanted angles 1 and 3, it would have to be that the top and bottom were parallel, and I don't have that given to me. So just those two angles. And so I'm going to go ahead and write that over here. Angle 2 congruent to angle 4. What would my justification for that be? What kinds of angles are those from the parallel lines? Yes, ma'am. Alternate interior angles. All right. Now, that's what I get from the parallel lines. The next thing it says in the given information, I'm just going to mark this as I go here. Angle R, which is right here, I'll put a double mark on that since I already put a single mark on a different one. And angle Q, those two. So just given to me in the directions, but hopefully marked in the picture so we can see it easier. But this is just given. Remember, these first 3 steps can come in any order. All right, now we've exhausted our given information. So we got to use the picture in some way to get something else. Can I have any other sides or angles in the picture here? Yes, ma'am. How come? Yes, you got that side in both. So PS and PS reflexive property. Okay, now, specifically for this question, you don't have to do this. I'm going to do it real quick, and I'm probably going to do a bad job. When I have a diagram that kind of looks like this one, where it's sort of like a parallelogram, I feel like these are really hard to do the congruent statement if you don't have it. So I'm just going to copy these 2 triangles, but I'm going to separate them from each other really quickly. And on my picture, at least, I'm going to relabel these with the markings that I had in the original. Okay, so we had this angle here, and then we had a reflexive property. Okay. Now, if you can see, they're not kind of oriented in the same way. It's almost kind of like rotated around and twisted a little bit. So let me call that first triangle, I'm going to call that PSR. Okay, if I call that first triangle PSR, how do I have to label the other triangle to make a situation where the corresponding parts match? SPQ, good. Okay, SPQ, if you're like, what the heck are you talking about? All right, so see how the P has a single curve? In this triangle, that's on S. And then I said S is my next one. That didn't have any mark on it at all. And so in this triangle, that's angle P. And then finally, the last letter I had, angle R, or R has that double mark on it. That matches up with Q in that other triangle. So sometimes when they're connected like that, it can be really tricky to make that statement. Once you got that, why are they actually congruent? Like which one of the reasons that we've been using? Angle, angle, side, sweet. And forgive, I probably should have started out with this. Whatever you're trying to prove, though, that should be the very last step. So even though I didn't know this initially, PR and SQ are going to have to be congruent now. So if you guys look at the diagram, SQ would be here and PR would be here, and you can hopefully see that side is between the single curve and the double curve angles there. Those are corresponding sides, and because the triangles are congruent, corresponding parts of congruent triangles have to be congruent to each other. So I know that's got to be the last step. Okay, let's try. This one has just a little bit different information. And then I have a little flow proof to practice as the last problem. Now, whatever you're trying to prove, do not mark that in the diagram because we don't know this. We're trying to prove this. But I am going to go ahead, I'm going to write that as my last step. So if I'm trying to prove sides or angles congruent, that's the last step. And I know it's going to be, we're going to prove the triangles congruent, and then I know I'm going to end up doing corresponding parts of congruent triangles or congruent. So I might go ahead and just write that at the end. I probably shouldn't tell you to do that, but I'm going to. Okay, now, I have the diagram, and then my given information besides that says B is the midpoint of both CD and AE. Okay, so CD goes all the way across here, right? So if B is the midpoint, if you get a midpoint, you're going to get two congruent segments from that. So B is right in the middle of this long segment here. So that's going to give me in the triangle C to B and B to D. Those two segments or those two sides have to be the same. So we can write these first three steps in any order, but that's what I'm going to write first. C to B and B to D. And that I just would say, because I know that they told me in the directions B was the midpoint, so this is just going to be definition of a midpoint. Okay, now it says B is also the midpoint of AE. So that's that whole line. So B is going to be right in the middle of that whole line. That's going to give me two different segments. So that's going to give me A to B and B to E. Those have to be congruent. So AB and BE. And same thing, just definition of a midpoint. Same thing. I have B being the midpoint of two different things there, so I get two different sets of sides. Okay, no other given information, so I got to get anything else from the picture. What else can I have from the picture that maybe I don't have marked up? Yes, yes, yes. Okay, angle 1 and angle 2 are vertical angles. So angle 1, congruent. Angle 2, vertical angles. Okay, now this one will be very tricky. So I'm going to call the triangle that's on the left side, I'm just going to call it ABC. Now, when you look at this one, and if it helps you, I could redraw it. I'll be happy to do that. But this is literally almost like somebody took a candy wrapper and twisted it, the way these are oriented in the diagram here. So when I say ABC, I'm going down double line on my paper, so A to B, that vertical angle, and then the single line. How would I have to label the other triangle? Bryn, what do you think? EBD. It's weird. It's kind of twisted. So make sure you really look at the diagram. Now, why are these two triangles here congruent? Side angle, side, good deal. All right, and then that forces what I already wrote down. That forces, if you guys see, angle C and angle D. Those are going to correspond. C and D are in the same place in my congruent statement, these angles have to be congruent to each other because they're going to be corresponding parts. And since we know the triangles are congruent, it forces those angles to be congruent as well. Okay, now one last one, a little flow proof down here at the bottom. And you guys know the flow proof has a little bit more information than I would ask you to do in a 2-column proof, because they just copy the given information, and I haven't been having you do that unless it's a set of sides or a set of angles. So it'll say we have this lovely diagram here, and it says UG, so that's going to be right here, this segment. It's going to bisect 2 different angles. So it's going to bisect BUH, so I'm just going to kind of extend that angle a little bit. And it's also going to bisect this other angle here, which is HGB. And I put some numbers in the diagram for us just to help save us a little bit of time. But literally all they're doing when they start this out is they are just copying that these 2 angles are being bisected. So these first 2 steps are just literally copying the given information. Okay, now here's how the flow proof goes. The first little thing says UG bisects BUH, that's the one I colored kind of in blue on my paper. So that would give me that angle 1 and angle 2 are congruent. What would I use as my justification for that? Yes, okay, so if I bisect an angle, it's got to be definition of angle bisector. Good. All right, so I'm going to put definition angle bisector here. So in the flow proof, what's in the box is basically what you would have as your statement in a 2-column proof, and what's underneath would be what you guys would have as your justification. Okay, now basically similar statement here, but it says UG bisects HGB. This is the one that I have in purple. So if I'm going to cut that angle into 2 equal angles, that's going to match up with angle 3 and angle 4 in the diagram. So I'm going to put angle 3 congruent to angle 4, and the justification there's already been filled in for us. Same thing we wrote above. It's just a different set of angles, but it's definition of angle bisector. And then the next step they have there, these are their 3 triangle parts here. They say UG is congruent to UG. That segment is in both of the 2 triangles there. That's just your reflexive property. Okay, that should be enough to show that those 2 triangles are congruent. So what reason would you use for those 2 triangles being congruent? Yeah. Yes, ma'am. Angle, side, angle. And then if the triangles are congruent, that forces any corresponding parts to be congruent. So if you guys can see, the angle H and the angle B here, those would be corresponding angles. So corresponding parts, in this case angles, of congruent triangles have to be congruent. So you got to show the triangles are congruent first, and then that forces any sides or angles that correspond to each other that you didn't know about, forces them to be congruent as well.
What's going on?